The National Electrical Code, or NEC, does not have a specific distance requirement for mounting a dry-type transformer away from a school building. However, it's a common and good practice to keep a safe distance. This minimizes the risk of arc flash and other electrical hazards that might happen. A reasonable setback distance for a dry-type transformer from a school building is generally around 10 feet. This provides enough space for maintenance, easy access, and safety. Regarding the main entrance switchgear location, the NEC says it needs to be in a separate room or cabinet. This room or cabinet must have a lockable door. This setup makes sure that only authorized people can get to the switchgear. NEC Section 110.26 provides guidance. It says equipment such as switches, circuit breakers, fuse holders, terminal blocks, and similar gear must be mounted so they can be easily accessed for inspection, maintenance, servicing, and replacement. Importantly, this section doesn't say the main entrance switchgear has to be in a fenced area. If the switchgear is in a separate room or cabinet that locks and can be accessed for inspection and maintenance, it usually meets the NEC requirements. Now, thinking about safety and security, it's a good idea to put the main entrance switchgear in a fenced area. This is especially true if it's near public areas. However, the NEC doesn't make this a mandatory rule. Other factors to think about include local building codes and fire regulations. These might have extra rules for how far transformers need to be from buildings and where switchgear should be located. You should also look at the specific transformer being used and what the manufacturer recommends. Safety should always be the main thing you consider when deciding where to put electrical equipment. Transformers are crucial components in electrical power distribution systems, stepping voltage levels up or down to match the requirements of different equipment and loads. Understanding the design, installation, and maintenance of transformers is essential for ensuring the safe and efficient operation of electrical systems. There are several types of transformers, including dry-type transformers, liquid-filled transformers, and auto transformers, each suited for specific applications and environments. Dry-type transformers are commonly used indoors due to their reduced fire risk compared to liquid-filled transformers, which rely on oil or other fluids for cooling and insulation. When selecting a transformer, several factors must be considered, including the voltage and current ratings, kVA capacity, impedance, and insulation class. The transformer's voltage rating must match the supply voltage and the voltage requirements of the connected equipment. The kVA capacity should be sufficient to handle the expected load, with some additional capacity for future expansion. Impedance affects the transformer's ability to regulate voltage under varying load conditions, while the insulation class determines the transformer's ability to withstand high temperatures and voltages. Installation of transformers must comply with the NEC and other applicable codes and standards. Proper grounding is essential for safety, as it provides a path for fault currents to flow back to the source, tripping over current protection devices and preventing an electrical shock hazard. Transformers should be installed in well-ventilated areas to prevent overheating, and clearances around the transformer should be maintained for access and maintenance. Regular inspection and maintenance are crucial for ensuring the reliable operation of transformers. Inspections should include checking for signs of damage, such as cracks, leaks, or corrosion, as well as monitoring the transformer's temperature and noise levels. Maintenance tasks may include cleaning the transformer's enclosure, tightening connections, and testing the insulation resistance. Switchgear is another critical component in electrical power distribution systems, providing protection and control for electrical circuits and equipment. Switchgear assemblies typically include circuit breakers, fuses, switches, and other devices that can isolate and de-energize sections of the electrical system for maintenance or in the event of a fault. There are several types of switchgear, including low-voltage switchgear, medium-voltage switchgear, and high-voltage switchgear, each designed for specific voltage levels and applications. Low-voltage switchgear is commonly used in commercial and industrial facilities to protect and control circuits up to 600 volts, while medium-voltage switchgear is used in substations and large industrial plants to protect and control circuits from 600 volts to 69 kilovolts. High voltage switchgear is used in transmission and distribution systems to protect and control circuits above 69 kV. When selecting switchgear, several factors must be considered, including the voltage and current ratings, interrupting capacity, and protection functions. The switchgear's voltage rating must match the system voltage, and the current rating should be sufficient to handle the expected load. The interrupting capacity determines the switchgear's ability to safely interrupt fault currents, while the protection functions provide automatic tripping of circuit breakers in the event of overloads, short circuits, or other abnormal conditions. Installation of switchgear must comply with the NEC and other applicable codes and standards. Proper grounding is essential for safety, as it provides a path for fault currents to flow back to the source, tripping over current protection devices and preventing electrical shock hazards. Switchgear should be installed in a clean, dry environment to prevent corrosion and other damage, and clearances around the switchgear should be maintained for access and maintenance. Regular inspection and maintenance are crucial for ensuring the reliable operation of switchgear. Inspections should include checking for signs of damage such as cracks, corrosion, or loose connections, as well as verifying the proper operation of circuit breakers, fuses, and other protective devices. Maintenance tasks may include cleaning the switchgear's enclosure, tightening connections, and testing the insulation resistance. The National Electrical Code, or NEC, provides comprehensive guidelines for the safe installation and operation of electrical systems. The NEC is updated every 3 years to reflect changes in technology and industry best practices. It covers a wide range of topics, including wiring methods, overcurrent protection, grounding, and equipment installation. Compliance with the NEC is essential for ensuring the safety of people and property. Article 450 of the NEC covers transformers, providing requirements for installation, protection, and ventilation. It specifies minimum clearances around transformers, as well as requirements for overcurrent protection and grounding. Article 408 of the NEC covers switchboards and panel boards, providing requirements for installation, protection, and wiring. It specifies minimum clearances around switchboards and panel boards, as well as requirements for overcurrent protection and grounding. Article 110 of the NEC covers general requirements for electrical installations, including requirements for working space guarding and access. It specifies minimum working space clearances around electrical equipment, as well as requirements for guarding live parts to prevent accidental contact. In addition to the NEC, other codes and standards may apply to the installation and operation of electrical systems. These may include local building codes, fire codes, and industry standards. Compliance with these codes and standards is essential for ensuring the safety and reliability of electrical systems. Proper electrical design is crucial for ensuring the safe and efficient operation of electrical systems. Electrical designers must consider several factors, including the load requirements, voltage drop, overcurrent protection, and grounding. They must also comply with all applicable codes and standards. Load calculations are essential for determining the size of conductors, overcurrent protection devices, and transformers. Voltage drop calculations are necessary to ensure that the voltage at the load is within acceptable limits. Overcurrent protection devices, such as circuit breakers and fuses, are used to protect electrical circuits from overloads and short circuits. Grounding is essential for safety, as it provides a path for fault currents to flow back to the source, tripping overcurrent protection devices and preventing electrical shock hazard. Electrical safety is of paramount importance when working with electrical systems. Electrical workers must be properly trained and qualified to perform electrical work, and they must follow safe work practices at all times. Personal protective equipment, or PPE, such as gloves, eye protection, and arc-rated clothing should be worn when working on or near energized electrical equipment. Lockout/tagout procedures should be followed to de-energize electrical equipment before performing maintenance or repairs. Electrical hazards include electric shock, arc flash, and arc blast. Electric shock can occur when a person comes into contact with an energized electrical conductor or equipment. Arc flash is a dangerous electrical explosion that can occur when there is a short circuit or other electrical fault. Arc blast is the pressure wave created by an arc flash, which can cause serious injuries or death. Regular electrical safety training is essential for ensuring that electrical workers are aware of the hazards associated with electrical work and that they know how to work safely. Training should cover topics such as electrical hazards, safe work practices, personal protective equipment, and lockout/tagout procedures. In summary, the safe placement of transformers and switchgear near schools requires careful consideration of the NEC local codes and safety best practices. While the NEC doesn't specify an exact distance for transformer placement, a 10-foot setback is a reasonable guideline. Switchgear must be in a lockable room accessible only to authorized personnel. Always prioritize safety and consult all applicable codes and standards to ensure compliant and secure installation. The NEC also addresses several other important aspects related to electrical installations in and around school buildings. These include requirements for wiring methods, grounding and bonding, overcurrent protection, and emergency systems. For example, the NEC specifies that wiring methods used in school buildings must be suitable for the environment and must be protected from physical damage. The NEC also requires that all metal enclosures and equipment be properly grounded and bonded to ensure a low impedance path for fault current. Overcurrent protection devices, such as circuit breakers and fuses, must be sized and installed to protect conductors and equipment from overloads and short circuits. Emergency systems, such as emergency lighting and fire alarm systems, must be designed and installed to provide reliable power and operation during a power outage or other emergency. In addition to the technical requirements of the NEC, there are also several administrative requirements that must be followed when installing electrical systems in school buildings. These include obtaining the necessary permits and inspections, and ensuring that all work is performed by qualified and licensed electrical contractors. It is also important to maintain accurate records of all electrical work, including drawings, specifications, and test reports. These records can be used to troubleshoot problems, plan future upgrades, and demonstrate compliance with applicable codes and standards. The NEC also provides guidance on the selection and installation of electrical equipment in hazardous locations. Hazardous locations are areas where there is a risk of fire or explosion due to the presence of flammable gases, vapors, or dusts. School laboratories, shops, and storage areas may be classified as hazardous locations if they contain flammable materials. The NEC specifies that electrical equipment installed in hazardous locations must be listed and labeled for use in those locations. This equipment is designed to prevent ignition of flammable materials by containing sparks, arcs, and hot surfaces. The NEC also provides requirements for the installation of fire alarm systems in school buildings. Fire alarm systems are designed to detect fires and alert occupants to evacuate the building. The NEC specifies that fire alarm systems must be installed in accordance with the National Fire Alarm and Signaling Code, or NFPA 72. This code provides detailed requirements for the design, installation, testing, and maintenance of fire alarm systems. In addition to the NEC and NFPA 72, there may be other local codes and standards that apply to the installation of fire alarm systems in school buildings. These codes and standards may specify additional requirements for the location of fire alarm devices, the types of fire alarm signals, and the testing and maintenance procedures. The NEC also provides guidance on the installation of emergency lighting systems in school buildings. Emergency lighting systems are designed to provide illumination during a power outage or other emergency. The NEC specifies that emergency lighting systems must be designed to provide adequate illumination for safe egress from the building. The NEC also requires that emergency lighting systems be powered by a reliable source of power, such as a generator or battery backup system. In addition to the NEC, there may be other local codes and standards that apply to the installation of emergency lighting systems in school buildings. These codes and standards may specify additional requirements for the location of emergency lighting fixtures, the types of emergency lighting signals, and the testing and maintenance procedures. In conclusion, the safe and reliable operation of electrical systems in school buildings requires careful attention to detail and compliance with all applicable codes and standards. By following the requirements of the NEC, local codes, and industry best practices, electrical designers, contractors, and maintenance personnel can help to ensure the safety of students, staff, and visitors.